Hi, this video is for 2.6 inequalities for my Math 161 students. I'm going to have about 7 examples to go over with you, and then I will assign 2 problems for you to try, okay? So we'll look at 2 types of inequalities today. The first one, well, let's just first title this as 2.6 inequalities. And first type, we're going to be solving polynomial inequality. Okay. This one, I'll give you the factored form first. And then I'll give you like example 4 and maybe 5. I'll make it more like what I want you to try for your classwork. So let's start with slightly easier one. Example 1. Write down solve x minus 5 times x minus 2 times x plus 7 is greater than 0. Okay, we're solving this inequality and the answers are going to be in interval notation, okay? So, first thing that you're going to have to do is to first find the zeros. So, step number 1, find zeros. Okay, let's find zeros. Look at the first factor I gave you is x minus 5. So the first zero is at x equals positive 5. Look at the second factor. I gave you x minus 2. Therefore, the second zero is at positive 2. And the last zero, x plus 7. From that factor, we will have x equals negative 7. Now, these are going to be called your boundary points. Okay? Now, these are the zeros. These are the zeros of this polynomial. So, after this point, do draw a number line. Do draw a number line for me with these boundary points. So, let me show you. Just going to draw a random number line with the smallest number, negative 7. Then the number 2. And then 5. Now, I'm going to draw a circle on these 3 boundary points. And the reason I'm drawing open circle, look, I'm drawing open circles on these points is because it says greater than. It simply says greater than 0. So I will use open circles at my boundary points. Now, if it was greater than or equal to, I would have closed these circles. So this is a good point. This is really good. Now take a look. We have how many intervals? We have 1 to the left of negative 7, 1 interval, 1 in the middle of these 2, 2, 3, and 4 intervals. We're going to test them all by plugging in a number. So give me a number. That's in this region. So anything smaller than negative 7. I'll pick a number negative like 10. Why not? You could have picked negative 11, negative 8, negative 6. Not negative 6. Anything smaller than negative 7 will work. I just picked a random number, negative 10. All right, plug in x equals negative 10 into your original polynomial, okay? So that will turn into negative 10 minus 5, negative 10 minus 2, and negative 10 plus 7, okay? And I want to see if it's greater than 0, but I'm just going to plug in negative 10 into these 3 factors and see what I got. Now look, I don't really need the exact number. I'm just going to get the signs here. So negative 10 minus 5, that's going to be negative, right? And this will give me another negative number, and this will give me another negative number. So if you multiply 3 negative numbers, you are going to end up getting a negative. So I'm just putting a whole bunch of negatives here, like just to say everything to the left of it will be negative, okay? Now, will this be my answer region? will that be a solution? No, because I'm looking for areas that are greater than 0. Now let's keep going. I'm going to plug in another value. Something that's in between -7 and 2. Every time you get like a negative number and a positive number, what's a good number that we can plug in? We're going to plug in x equals 0. Okay, 0 is in between any negative and a positive number. So I'm going to plug in 0 here. Then I'll get 0 minus 5, 0 minus 2, and 0 plus 7. Okay, what's that going to be? 0 minus 5 is -5. That's a negative number. 0 minus 2 is a negative number. And 0 plus 7, that's going to be a positive number. Take a look. If I multiply two negatives and a positive together, these two will turn into positive, and positive times positive is positive. So the answer will be a positive number. What I know then is everything in between these three, these 2 points are going to be positive. And I just put 3 positive signs here just to say like everything in between them are positive. Not saying I'm multiplying 3 positive numbers, just anything in between these are going to be positive. In fact, we found one of the answer region, didn't we? Because we're looking for everything that is greater than 0. So one of the answer is going to be that region right there. But look, I got 2 more intervals to test. And I'm just going to keep on plugging in. But I do want to talk about the multiplicity and whether the graph will cross or touch the x-axis at these boundary points. Because you do know something about even and multiplicity. I'm out of room, but let me just draw an arrow to do some work here. Give me a number that's in between 2 and 5. What's a number that's greater than 2 but smaller than 5? I'm just going to go with x equals 3. Okay, so let x equals 3. I'll plug in x equals 3 here. So that will be 3 minus 5, 3 minus 2, and 3 plus 7. Let's see what that will give me. The first number will be negative. This will be positive. And then this one will be positive. If you multiply negative times positive, the sign will be negative, right? So this interval will give me a negative number. I plug in. So that's not my answer region because I'm looking for an interval that will give me numbers that are greater than 0. So that's not it. I'm not going to highlight it. And let me do the very last interval, which is over here. Let's plug in a number that's just greater than 5. Maybe like x equals 6. If I plug in 6, I will get 6 minus 5, 6 minus 2, and 6 plus 7. Let's see the signs here. This is positive. This is positive and another positive. If I multiply 3 positive numbers together, I will get a positive answer. So the last region that interval that we just tested also came out to be positive. Now take a look. I just have these two these two intervals highlighted with my yellow Sharpie because I'm looking for something greater than 0. Greater than 0 means positive number. So these are the ones that came out positive. So let me write my solution, okay? So here's how I write the solution in interval notation. The solution. Okay, the first region or interval is from -7 to +2. With open circles, that will be -7, 2, but do put regular parentheses, not bracket, okay? Union. What's the second region? 5 to, keep on going, right? 5 to positive infinity. And that's how you solve a polynomial inequality. And this one, we were given something that was already factored. So prepare for the ones that are not factored, then you have to do a little more work before. But let's try another one. Before I get there, I want to point something out. Okay? Do you notice how it was negative here and then it crossed to the positive side? And then it crossed back to negative, and then it went up to positive again, right? It was crossing. And you know you were expecting this because you knew that because these multiplicities, the multiplicity of these zeros are all 1, one being an odd number, the graph will cross. So negative to positive, it crossed. Positive to negative, it crossed. Negative to positive, it crossed. So instead of plugging in 4 different numbers to test these intervals, you can use that, but it's not always going to cross, okay? So maybe the second one, I'll show you a case where it's not going to cross. No, not yet. I told you that I'm going to do like 7 examples today. So I'll really do all those 7 examples with you. All right, number 2. Write down example 2. And this one, I'm going to ask you to solve, but still solving a factored form. X plus 2 times x minus 4 times x plus 6, and say that is less than or equal to 0. So let's solve this, and you know how to start. We're going to find the zeros first. Find zeros. What are they? X equals, oh, let me hit the focus button 1 second. Looking at x plus 2, you know the first 0 is at negative 2. Looking at x minus 4, you know the second 0 is at positive 4. And then the last one, x plus 6, the third 0 is at negative 6. Now what do? We graph these on a number line, right? So on a number line, plot the smallest number on the left, negative 6 is the smallest number. Plot the second smallest number, negative 2. And then positive 4 is the greatest number here. Now I'm going to draw circles, and you decide whether we're going to close these circles or leave them open. What do you think? It says less than or equal to 0. So these are the points where the function is 0. So this is the case where we have to close the circle. Okay? So we'll be using brackets this time when we write the final solutions. But now I have 1, 2, 3, 4 intervals to test. So what's the good number that I can plug in here? Plug in x equals negative 7. Okay, plug in x equals negative 7. So what I'll do is negative 7 plus 2. I'm plugging in negative 7 here, here, and there. Okay, next, negative 7 minus 4 and negative 7 plus 6. And I just did the signs earlier, but I can also just type this in, negative 7 plus 2, negative 7 minus 4, negative 7 plus 6. What kind of number do we get? We get a negative number. I don't care about the 55. I could have easily picked like negative 8 and negative 10. All I care is that it came out to be a negative number. So what I'm going to put is a whole bunch of negative signs, or just like enough for you to see, oh, everything to the left of it will be negative. In fact, we actually found one of the answer region, right? Answer interval. All right, let's find something else. Let's test all of them. But you already know this will be negative, positive, because the multiplicities are all 1, odd multiplicity. Therefore, they're going to cross. But you know, it's always good to test them. Actually, plug in numbers. Plug in, what's the good number here? X equals anything in between negative 6 and negative 2. I'll use negative 5. Okay, I'll use negative 5. Then negative 5 plus 2, negative 5 minus 4, negative 5 plus 6. Let me see what that's going to give me. I am expecting to get a positive number, right? Negative 5 plus 2, negative 5 minus 4, negative 5 plus 6. That gives me a positive 27. Not that we care about the number 27, we just care that it came out to be a positive number. So I'll just put plus, 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 plus here. Got 2 more regions to test. Ooh, look, got a negative on the left, positive on the right. What's the good number that we're going to use? X equals 0. So if you plug in 0, what will we get? 0 plus 2, 0 minus 4, and 0 plus 6. That will be 2 times negative 4 times positive 6. And that number will come out to be negative whatever. So because we have a negative sign right here, so I know I'm just going to put negative, negative, negative. You see though, it's crossing negative to positive, positive to negative, and I'm expecting the last one to be positive with odd multiplicities, right? Because the multiplicity is odd, we know the graph will cross to the other side at these x-intercepts. But why not? Let's test another one. Let x equals, give me a number that's bigger than 4. Okay, 5. 5 plus 2, 5 minus 4, and 5 plus 6. That will be 7 times 1 times 11. And you can see if you multiply positive numbers together, you will get a positive number back. Okay, so let's write the answer region. I use my highlighter to highlight. I'm looking for things that are smaller than or equal to 0. Take a look. We're looking for area that are smaller than or equal to 0. So I want all the negatives. So here's my first answer region. That one. and another negative right there. I am going to write the solution in interval notation now. So solution, okay, this one right here, what's that going to be? From negative infinity to negative 6. But after negative 6, you see that's a closed circle. Draw a bracket. Union. Skip this one. That's positive. We don't want that. From negative 2 to positive 4. So bracket negative 2, comma 4, and the square bracket. And that is it. That's how we solve another one. We just tried another one, but I just wanted to show you this because it came out to be a closed circle with brackets. But now, you've seen two examples where the graph was crossing, like negative to positive, positive to negative, negative to positive. The first one was like that too. But now I want to show you the case where you can't always assume it's going to cross. So example 3, you will see an example that has an even multiplicity, okay? Let me get another piece of paper. Number 3. And in this example, again, I will give you a factored form. Right, solve x minus 2 times x minus 7 squared is less than 0. Okay? So, let's first find the zeros. Find zeros. Okay? What are the zeros? X equals positive. Come on, focus. It's getting blurry all the time. X equals positive 2 and x equals positive 7, right? So graph them. 2 and 7, and I draw a circle here. Now, should we leave them open or close them? Look, it says less than 0. It doesn't say less than or equal to 0. It's less than. So leave them open. Okay? So real quick notes. If you get these ones, leave them open. If you get less than or equal to, greater than or equal to, those are the ones you have to close. Okay? Alrighty. What should I do? Yeah, we should plug in numbers now. Give me a number that is smaller than 2. Plug in x equals, what's a number that's smaller than 2? 0. I'll plug in 0. So plug in 0 here and plug in 0 there. That will be 0 minus 2 times 0 minus 7 squared. Okay? And you are looking at me being a little lazy. 0 minus 2, 0 minus 7 squared. That will give me a negative whatever, 98, okay. But I just know that it came out to be negative. Alright? So I'll write down this side was negative. Negative, negative, negative. Now, if you're being kind of a little careless, you're just going to stop plugging in points and you're going to say, oh, this will be positive and this will be negative, and that will be wrong. So I want to show you why. So this one, let's plug in x equals, what's the number that's in between 7 and 2 and 7? For some reason, I want to use 5. And 5 is fine. If you want to use 3, 4, or 6, that's also okay. 5 minus 2 times 5 minus 7 squared. And what's that going to give me? 5 minus 2 times 5 minus 7 squared is a positive 12. Positive 12. Not that we care about the number 12, but we just know that it came out to be positive, so I put the positive sign there. And you know, you're saying, oh, the signs are alternating or signs change from negative to positive. And I know that's okay, because the multiplicity of this x minus the 0, 2 was just odd 1. So we it's okay that it crossed. That's what we were expecting. But what I want to show you is that with the even multiplicity, this is even number, it's not going to cross down to the negative side. Okay, it's actually gonna just touch the 7 and go right back up. So we are expecting to see a positive number here. Let's see. Plug in a number that's greater than 7. I'm going to use 10. I'm just going to plug in a random number that's bigger than 7. And I picked 10. 10 minus 2 times 10 minus 7 squared. What's that going to be? 10 minus 2 times 10 minus 7 squared. And look, that came out to be positive number. Positive number. So a sign right here is going to be plus, plus, plus. So see, this is a case where the graph did not cross to the other side. It just touched the 7. This is where it was 0 and went right back up. Alright, so let's find the solution. We're looking for area that is smaller than 0. Smaller than 0 means we need the negative. Okay, so let's write that solution. Solution. We just have one interval. From what? From negative infinity to number 2. And then it's an open circle, right? Use a parenthesis. So that is the answer for example 3. Now you've seen enough of the forms that are factored out for you already. Oh, now I'm going to go ahead and go over the ones where you have to factor yourself. Okay, you have to factor yourself. Why not? Let's review factoring by grouping. Example 4. Example 4. I'm going to give you a polynomial that you're going to have to do some work before you can see or find the zeros. So here you go. Write down solve x cubed minus x squared is less than or equal to 9x minus 9. All right. Now for this one, you see it's not easy for us to just look at it and find the zeros because it's not factored out yet. Now we're going to factor it together there, okay? If you get a problem like this on your homework or your exam or your classwork, move everything to the left side first, okay? Let's move everything to the left side first. So I'm going to keep my x cubed here, and then minus x squared. But the positive 9x, if I move it, that's going to turn into negative 9x. And then this negative 9 will turn into what? Plus 9. And there's nothing left on the right side. So what number should we put for nothing? 0. So first thing that you're going to do is you're going to move everything to the left side. And then let's try to factor this. You know how to factor this by grouping. We cut this in the middle. Let me cover the second half. I'm just going to focus on the first half. X cubed minus x squared. Their GCF is just x. So factor out the x. You're going to have x squared minus, oh, whoopsie, my mistake. Their GCF is not just x. It's actually what? X squared. So I was wrong there. Let me fix it. So factor out x squared. Factor out the greatest common factor, not just a random common factor. So if I factor out x squared, that will be x minus 1. I'm done with that half. Now I'm looking at the second half right here. Let me cover this up because I don't want to look at it yet. Negative 9x and positive 9. Their greatest common factor is negative 9. And remember to follow the sign of this third term. This one was negative, so factor out negative number, okay? So if I divide both of these by negative 9, I will get x minus 1, okay? Now remember, when you are factoring by grouping, you are expecting or you're trying to get the common factor that we can actually pull out. So you notice x minus 1 repeated, so write that down, x minus 1. But what's the other factor? Remember how to find the other factor. The other factor is going to be from the greatest common factors that you just factored out. X squared minus 9. So do write that. And that's still less than or equal to 0. Now you notice this also can be factored. Keep the x minus 1, but x squared minus 9, that's different. That's a difference of perfect squares. So you'll write that as x plus 3 times x minus 3. And now guys, look, this is where I got you started on examples number 1, 2, and 3. It took us about like 4 lines to get there, but now we're going to go ahead and solve this, okay? Remember, find zeros. Find zeros. What are the zeros here? X equals positive 1, x equals negative 3, and x equals positive 3. Now these are the 3 zeros or boundary points that I'll plot on my number line. Okay, you ready? So let's go ahead and graph or draw a number line. Negative 3 is the smallest number. 1's next, and then 3. What type of circles? Let me draw the circles here. Circle, circle, circle. Okay. Remember, we're solving this. Is less than or equal to 0. So I'm going to close these circles because it's less than or equal to. Close the circle, close the circle, close the circle. I'm going to plug in just one value. That's to the left of it. You know why? Because you notice the multiplicity is 1, 1, 1. Odd multiplicity, guys, that means it's going to cross. Okay, and I think we've seen enough that if you have odd multiplicities, yeah, well, and that was one of the theorems that we talked about a while ago. Plug in one of the value here, and we're just going to plug in one of these. Plug in x equals -4. I'll plug in -4 in here, okay? -4 minus 1, -4 plus 3, and -4 minus 3. Tissue. Oopsies. -4 minus 1, -4 plus 3, and lastly, what was it? -4 minus 3. Hit enter. I got a negative number, -35. Okay, so I'm gonna say this sign is negative. The sign to the left of it, didn't I just get a negative? Why am I writing a positive, right? Negative, sorry. But here we go. I was going to plug in, and I suggest you do if you're taking like an exam or like a classwork that you're getting graded for. But to save some time, guys, odd multiplicities, right? So do you believe me if I say they're going to just cross negative to positive and positive to negative and negative back to positive? So that's it. That's it. I'm going to go ahead and highlight all the regions that are less than or equal to 0. Less than or equal to 0 right here. Less than or equal to 0 right here. So these are my solutions. Let me just write them down in interval notation. Solution. The first one is from -infinity to -3, bracket, union. Now let's write this one from 1 to what? 3, right? From 1 to 3, but around 1 and 3, I'm using brackets, right? Because we used a closed circle because they are less than or equal to 0. So that was an example where you had to do a little more work before you could actually get down to the solving part. But I want to do one more. I want to do just one more, and in fact, I think I'm going to do one that it's similar to one that you will try for me for classwork. In fact, let me stop the video after example 5 because the second part, solving rational inequalities, is a little different. So I'll just record another one, okay? So example 5 and then classwork. Oh, you see my camera there. Example 5, this is my last one, and I should probably example 5. I'm gonna actually open up one of the exam problems that I gave last semester. Ooh, let's do this one. Try this. Write down x cubed minus 40x is less than or equal to -3x squared. Now, watch very carefully. I'll give you something like this for your classwork, okay? Example 5. We need to factor this, right? We need to first move everything to the left side. And as I was planning on this moving, I saw this was x cubed. So I know that's the biggest, that's the 3 is the degree. So I will write x cubed first. But when I move this, I'm going to actually just stick it right in the middle of these two terms. You see why though, right? Because this is x to the 3rd power. This term will be x squared, and that one just has x. So I'm going to have plus 3x squared in the middle. And then minus 40x less than or equal to nothing left here. So put 0. Let me hit the focus button. It goes blurry Okay. So that's my little moving that I started first. And then take a look. What do they all have in common? X cubed, x squared, and x. They all have x in common, don't they? So factor out that x. Write the x in front of it. X squared plus 3x. Everyone will lose one of their x's inside. Minus 40. Close the parenthesis. And that's still less than or equal to 0. Now, you know how to factor this trinomial right here. Keep that x there, but think of two numbers that multiplies to give you -40. What times what is 40? 5 times 8, right? But if I want to make their product to be negative, I want one of them to be negative, one of them to be positive. Which one should we make negative? To add them and get a positive 3, I want my 5 to be negative and 8 to be positive. So just be careful on these little things, okay? Because I know your number line and everything that you do from that point on will be wrong if you just make a simple sign mistake. So we have, and in fact, let me double check. Doop, doop, they multiply to be negative 40. Doop, doop, they add up to positive 3. Okay, that's good. Now what do we do? This is where we find the zeros or the boundary points. Find zeros. And a lot of times people forget about this little x. The whole thing will turn into 0 if this x is 0. So put x equals 0 as your first 0. What's the next one? Positive 5. And then the last one will be negative 8, right? Okay, we found them all. Let's graph them on a number line. Smallest number is negative 8. Next number is 0. Next number is 5. I'm going to draw circles, but let's think. Let's look at it. Should we close these circles or leave them open? It says less than or equal to. Less than or equal to means you're going to close these circles. Close it, close it, close it. Because at these values, the function or this polynomial is at 0. Now let's plug in and look at the multiplicity for me real quick. This is x to the first power. This is x minus 5 to the first power, x plus 8 to the first power. Again, we're looking at a case where they all have odd multiplicity. So if I just figure out the one on the left, I know everything else will just alternate, right? So let x equals what number? Negative 9. I'll plug in a number that's smaller than negative 8. And a number that's smaller than negative 8, I just got negative 9. Let's plug in. So, and you're wondering, where should I plug this into? I just plug it into, and it really shouldn't matter, but I'm just going to plug it in here because I'm trying to get the sign here. That will be negative 9 times negative 9 minus 5 and negative 9 plus 8. I want to get the sign of this, so I'll take a look. Just going to check it. Negative 9 times negative 9 minus 5 and negative 9 plus 8. The sign is negative 126, but all I care is that this came out to be negative. Now look, if that one is negative, at negative 8, whose multiplicity is odd, 1, it's going to cross to positive side, and everything else, positive down to negative, and negative back up to positive. So, and you really have to be careful because sometimes I will throw in these even multiplicity problems, and I do plan on doing that. Oh, I will do that on your work. I'll give you 2 problems after this, and I'll make sure to give you one that has all even multiplicity. All right, so let's go ahead and write the solution. I want things that are less than or equal to 0. Less than or equal to 0 means negative sign, negative number. So these are it. So write these down. So here are my solutions. Solution. The first interval is from negative infinity to negative 8, bracket, union. And the second one is from bracket, union of 0 to 5. Okay? I think that's enough for solving rational, not even rational, solving polynomial inequalities. And I'll come back and show you 2 examples on the other type of inequality that I want to solve for in 2.6, the rationals. But after watching this video, I'm about to stop it in just a second. I am assigning you 2 problems for you to try. Okay, so write these down on a separate sheet of paper for me. Here is the first one. Number 1. Classwork. Number 1. Solve x cubed minus 12x is greater than or equal to x squared. It's similar to that last example that we just went over. That's the first one. And let me give you another one. Solve, and I think I want to make you factor. Why don't you give me 1 second? So you write that down. You know what though? I think I know how to stop the video. I'm gonna stop the video for 1 second. Alrighty, I wrote it down. So the second one I made up. x cubed plus 27 is less than 3x squared plus 9x. So you're going to have to move these two terms first. Factor by grouping. I made sure that this is factorable by grouping method. And you know what? I made it so that you will get one of the zero to have even multiplicity. So you should check those multiplicities very carefully, or just make sure to plug in all those values in all those intervals, okay? Now, that's enough for solving polynomial inequalities. I will be back with some examples on solving rational inequalities, okay? All right, try these for me now. Thank you.